Here's a nice problem on using techniques in calculus to figure out what two charges must be. So the problem is you have two positive charges which are separated by a distance d, and you are required to keep the sum of the two charges to be equal to some value capital Q sub t. That's the total charge. However, you can divide up the total charge into two separate parts, and in such a way that you maximize the force between the two charges. So the question is, how should you divide the two charges? The second part of the question is, how should you divide them so that the total force is a minimum? So let's go ahead and solve the problem. We start by setting one of the charges to be denoted by little q. Then the other charge obviously is the total charge q sub t minus the little q. Once the two charges are known, of course you can use Coulomb's law, straightforward way to write down the force, and the force of course is F equals the constant k times the little charge q times the remaining charge q sub t minus q divided by the distance squared. But the distance of course is fixed, and this of course can be written in this way. To find the maximum and the minimum force, what we do is use the method of calculus. We first calculate the first derivative of the force expression with respect to the charge and set that equal to 0. So let's go ahead and do that. We also use the second derivative test as well. So differentiating the expression for F with respect to Q gives us the following expression here. You set that equal to 0, and that immediately tells you that the little q has to be half the total charge. So this is the condition that you need in order to get the extremum. So you could have either a maximum force or a minimum force. So we check the second condition, that is the second derivative has to be negative in order for there to be a maximum. So if one differentiates the force again with respect to the charge, you get minus 2k divided by d squared. And note that here everything is positive. K is positive, d squared always is positive, of course, and therefore this entire quantity is always negative. Hence the solution that we found, q equals half q sub t, gives you the maximum force. So that would be the condition for giving the maximum force. That means you have to distribute the charge half and half between the 2 points. Now in order to find the minimum, of course, since this is always true no matter what q is, you get the minimum condition only when one of the charges is 0. So if one of the points has 0 charge, then the other has a full charge, and the product of course will be 0, and that would be the minimum force.